So we have a MacBook Pro. It says it's dead, and it says that it's urgent. So which means you have to be quick on this one. It's an A1502. So this is either going to be a 2013, 14, or 2015. First thing first, let's take the back cover out, and then you can confirm what year it is. Have one screw missing. Okay, back screws are out, and this is a 2013, 2014. Okay, it's now the 2015. If it was the 2015, we should see the trackpad cable should go over the battery. Okay, first thing we want to do is we want to disconnect the battery. We do not see any sign of liquid, which is we can say it's somewhat safe to connect charger to it. That way we get an idea what state the device is in. Okay, let's connect our charger. Okay, so we have charger indication, LED is on, and would have no fan spin. So this is not a 20. If this was a 2015, not having a fan spin wouldn't be an immediate concern, because with 2015s, your fan would not come on until the CPU gets warm. But with 2013, 2014, the fan starts from the time the machine goes into SO state, from starts to finish, the fan will start until the device is switched off. So we don't have fan spin. That gives us an indication that we do not have. This is a no power device. So the first thing we want to do is we want to check out the basics. We are not going to worry about checking out our PP3V42. Okay, let's quickly open up the board view. This is going to be an 820-0s 3437 3435. No, 346 3765. Okay, 37. I'm mixing up the numbers. 3476, yeah. So this is going to be an 80-3476 2013 2014. So we are not going to worry about PP3V42, because we have our charger indication. PP342 is required for charger for the charger to communicate with the device, the LED that we're talking about, the one that we see now. We're not going to worry about that. The next thing we want to check out is our PP bus. Let's see what we have on our PP bus real. That we can confirm from this resistor here, where it says PP bus. Let's see what we measure on our PP bus. 12.6 will tell us that our SMC is running at the level of the PP bus. That's fine. So our SMC is running at the level of the PP bus. Now let's see, are we partially making our way into SO state? We can confirm that at L7520. Let's see what we have at L7520. No voltage. Okay, no voltage at L7520 tells us that we are not making our way into SO. So what you want to do is you want to quickly take the board out, then get an idea what is happening. So we have confirmed that we have PP3V42. We have confirmed that our PP bus voltage is also present. And we confirmed that we are not making our way into SO state. So the next thing we want to do is we want to quickly take the board out. So we will be doing a visual inspection on the board, and then we'll also be measuring for short on the board. So let's take the board out, and then yeah, then take it up from there. Okay, our board is out. Let's put the shell on the side. So let's do a visual inspection of the board. Let's see if anything stands out. So usually I would start from either my right to my left or from my left to my right. So that will give me a better chance to spot anything that stands out. Okay, so far the only section we spot to seem to have a bit of a concern, it's the clock circuitry, which is this section here, and nothing else. So what we want to quickly do is see if we have a short. Let's take a random measurement to see if we have a short. Okay, we don't seem to have a short. It seems our um, okay, let's open up that section of the board, and that is the section of Y1900. That is where you have, that's our clock circuitry, and okay. So it seems we have, let's see if that pad is affected, because you have a bit of corrosion at that section. The pads seem okay. The pads seem just fine. Let's see, do we have a short on our PPV RTC line, which might be due to that cap? Let's see if we have a short on that line. And we don't have a short. Okay, let's replace that cap, and also let's see, Y1905. We are also going to remove Y1905 to confirm we have continuity still to Y1905. That cap was not looking good. Okay, so that cap was not looking, one part of the cap was completely off. It scratched too hard. Okay, let's try get another pad. Okay. Okay, let's get a donor board. So we are going to be replacing Y1905 and C1910. Okay. Okay, let's try now. There you go. So now we see, so you guys can see we have a fan spin. So basically what was happening is there was a bit of a corrosion at this section of the board, and C1910, the pad pin 1 of C1910 was affected. And then basically what will happen is that will affect, I mean, liquid in this region of the board will affect your PPV RTC underscore G3 hot voltage, and that is required for the machine to run. Without that rail functioning, you will not have a machine, you will not have a working board. And then as you guys can see, so basically what we had to do was to the part pin 1 of C1910 was gone. We tried to get another part here, which we scratched too hard, and then we broke the initial part. So we had to we had to put a solder, a big solder here, and then also quite a big one here, which is so you guys can see, in order for our capacitor to fit. So that's what we did. We had to put like a big solder there and then another one on the ground in order for our cap to fit, and then we replace U19 and then you replace U1905, and that's it. And I'm just gonna see that we have display on our screen, and this should be a completed repair. Okay, for me, for this, I just need the screen connected, and I have already this DC jack on the board, so I'm not going to connect other cables. I just want to see if we have image on our screen. We have fan spin. So do we have image? There you go. That's a beautiful Apple logo. Okay, so as usual, this is going to go through the guys to assemble it. They will assemble and do the test, and yeah, and then this can go to the client. Thank you guys. I will see you guys in the next one.